Have you ever gazed up at the night sky and wondered about its most extreme inhabitant? We often talk about black holes, those cosmic vacuum cleaners, as the ultimate abyss. But what if I told you there is something out there that could give you a far more bizarre, and frankly, more terrifying end? Today, we're diving headfirst literally into the mind-bending physics of a neutron star. What would happen if you fell into one? Trust me, it's worse than you can imagine. First, let's get acquainted with our celestial monster. A neutron star is the collapsed core of a massive star that went supernova. Imagine something with more mass than our sun, crushed into a sphere only about 12 miles, or 20 kilometers, across. That S-like cramming the entire city of San Francisco with the weight of 1.5 suns. The density is staggering. A single sugar cube of neutron star material would weigh as much as all of humanity combined. It is so dense that the protons and electrons in its atoms have been forced together to form neutron suns. The name? Now, let's start our unfortunate journey. Your spaceship's navigation has failed catastrophically, and you're on a collision course. Long before you get anywhere near the star, you'd be in serious trouble. Neutron stars have magnetic fields that are trillions of times stronger than Earth's. We're talking quadrillions of Gauss. This isn't just a compass-spinning inconvenience. At this intensity, the magnetic field would literally tear you apart at the atomic level. The atoms in your body would be stretched into long, thin needles. Your very molecular structure would unravel. You wouldn't even be a collection of cells anymore. You'd be a stream of subatomic particles, all aligned with the magnetic field lines, spiraling toward the star. So, your journey ends before it even really begins, disintegrated into a plasma whisper. But for the sake of science, let's pretend you have a magical, magnet-proof suit. What's next? The single most powerful force you'd encounter: gravity. The gravitational pull on the surface of a neutron star is about 200 billion times stronger than on Earth. As you fall, the difference in gravitational pull between your head and your feet would become immense. This is called the tidal force. It's the same force that causes ocean tides on Earth, but ramped up to an absurd degree. The star would pull on your feet so much more strongly than on your head that you'd be stretched like a piece of spaghetti. This process has a wonderfully graphic name: spaghetti. You'd be stretched longer and thinner, pulled into a string of atoms before you ever hit the surface. It would be a quick, but unimaginably violent end. Okay, let's keep layering on the magic. You're magnet-proof, and you're now just moments away from impact. What do you see? You'd be moving at a significant fraction of the speed of light. We're talking over 100,000 miles per second. Thanks to Einstein's theory of relativity, time would slow down dramatically for you relative to the outside universe. Also, the star's immense gravity would bend light around it, creating bizarre visual distortions. The sky would warp, with stars appearing in strange positions. The neutron star itself wouldn't look like a simple sphere. You'd see its entire surface, even the part on the back, as light from behind it is bent toward your eyes. It would be a terrifying, all-encompassing sight. And then, impact. Hitting a neutron star isn't like hitting a solid object. Remember that density? You'd slam into a surface harder than anything we can comprehend. The energy of your impact would be colossal. Your body, moving at near light speed, carries an incredible amount of kinetic energy. The moment you hit the surface, all that energy would be converted into a massive explosion of gamma rays and other high-energy particles. You wouldn't just be obliterated, you'd be annihilated. Your mass would be converted into pure energy, unleashing a flash brighter than 1,000 suns. A brief, brilliant testament to your disastrous final moments. It would be the most spectacular firework in the cosmos, with you as the main ingredient. So why is this worse than a black hole? When you fall into a black hole, you cross the event horizon, the point of no return. From the perspective of an outside observer, you appear to freeze in time and fade away. For you, the journey continues until you reach the singularity. It's a one-way trip, but it's a journey into the unknown. With a neutron star, there's no mystery, no gentle fade to black. There's just brutal, overwhelming physics. You're torn apart by magnetism, stretched into noodles by gravity, and finally, vaporized in a blaze of glory upon a surface harder than diamond. It's a series of cataclysmic events, each one more destructive than the last. There's no event horizon to hide behind, just raw, exposed power. The neutron star doesn't just swallow you, it utterly demolishes you in plain sight of the universe. The cosmos is a place of incredible beauty and unimaginable violence. Neutron stars are a perfect example of this duality. They are the lighthouses of the universe, spinning pulsars that help us map the galaxy, but they are also cosmic anvils, capable of destruction on a scale that defies our everyday intuition. So, while black holes may get all the attention for being the ultimate cosmic trapdoors, remember the humble neutron star. It offers a fate far more tangible, immediate, and arguably far more terrifying. Exploring these extremes helps us appreciate the delicate balance that makes our own little blue planet possible. Thank you so much for joining me on this rather grim but fascinating cosmic journey. What other celestial horrors would you like to explore? Let me know in the comments below. And if you enjoyed getting your mind spaghettified by astrophysics, don't forget to like this video and subscribe for more deep dives into the wonders and terrors of our universe. Stay curious, and I'll see you in the next one.